I think because I thought I was wrapping, the video cut off. Actually, no, I was kind of getting into the math and I lost my time. So hopefully I can do this, clean this up in less than 10 minutes, my chablitos. Okay, so we've got this vertical line, and vertical lines are going to give me an x equal line, right? So this is x equals, let's see, -1. So that's the a of S, axis of symmetry. I'll leave that there. And then finally, the other thing we need to do is come up with the y-intercept, which is easy. We're like profesh at this. We can just look at the equation. We see it's 3, but we look at the line, the actual graph, and we can see that it's 3. So the y-intercept, I'll do y-int, is equal to 0, 3. Notice I write a point for these two and an equation of a line. So x equals -1 is the axis of symmetry, not just -1, right? And the vertex is a point -1, 4, and the y-intercept is not just 3, but 0, 3. It's that point. All right, let's go ahead and look at this next example over here. And this should be really pretty speedy for most of you at this point. So if we go and we look for the vertex, we go right down here, we see that the vertex is at 1, -4. We see that the axis of symmetry is of the line x equals 1, because it would be right here. Zoop, go straight through the vertex. Notice, really, really nice, that's always going to be the case. The x term of the vertex, as long as it's oriented like this and like this. Later in Algebra 2, you'll see parabolas that are oriented on the side, slightly different, but same concept. The x, the value of the x term in the vertex is going to be 1. It's going to be the same thing as the axis of symmetry. All right, and finally, I think we did the other one in green. The y-intercept is, in this case, going to be right here at -3. So it's 0, -3. And I think at this time, you guys are professional. I can let you do this one on your own. Pause it and do it on your own, and I'll come up with the answers for you as soon as you're back. All right, and there you have it. I think you guys probably came up with exactly the same thing as I did. All right, let me know if there's any questions, and I look forward to talking to you about that later. Let's get to the next example. So this is really going to be important. We're identifying characteristics of a function, and here's the deal. It says find the vertex, the equation of the axis of symmetry, and the y-intercept. So we're looking for those same 3 things as last time, right? We're looking for the vertex. We're looking for the axis of symmetry, and we're also looking for the y-intercept of each of these. Now, in order to find that, do we have to graph it? The answer is no, but there's some really important points and concepts we need to kind of figure out. So here's kind of a mini lesson about how to get through these problems without graphing them, which is kind of cool. We can look at the equation and find some really good information. So the vertex, well, the axis of symmetry we can do really quick off the bat, right? So I'm going to actually do those first. So looking at this, the axis of symmetry, we talked about it before. That's just that -3 there, but we write it as a point, 0, -3. Can you guys tell me what the axis of symmetry, or not, I'm sorry, I said axis of symmetry, rewind, my bad. The y-intercept is right here, y-intercept, y-intercept, my bad. So can you tell me what the y-intercept would be down here? Hopefully you got it really fast, 0, -4. So that's cool. But the other 2 things, to find the axis of symmetry and to find the vertex, is going to take a little bit of work. And so the key here, this is a concept, important concept, I'm going to put it up at the top. The axis of symmetry is found by using -b over 2a is equal to x. So this is an equation. This comes kind of back, I know we've kind of talked about, I think we've talked about the quadratic formula. This comes from the quadratic formula. If you remember the quadratic formula, -b plus or minus the square root of b squared minus 4ac over 2a. -b over 2a is like this little piece here. That little piece there. And so all the, I know, let's talk about it in class. Anyway, for all intents and purposes, to get the axis of symmetry, the equation is, I'm sorry for going down that path. If this is kind of intriguing to you, let's talk about it in class. Not necessary. I know the book doesn't actually talk about it yet, so we can talk about it later. I apologize. I love you. I love you. Okay, so -b over 2a is the formula. So what a, of course we're talking about y equals ax squared plus bx plus c. So we're using the a and b when we have in a standard form. So to find the axis of symmetry, let's do that for both of them. So x is equal to negative b over 2a. So negative b, where's that? Negative b, here's b, 4, negative b. So negative 4 over 2 times a, over 2 times 2, right? And then so I get negative 4 over 4, which is negative 1. So the take-home point is x equals negative 1 is the equation of the axis of symmetry for this one. Let's do the same thing here, axis of symmetry for this guy over here. It's negative b over 2a. So x is equal to negative b over 2a. What's b in this case? B is 6. So negative 6 over 2 times a. What's a in this case? It's negative 1. 2 times negative 1. What I end up with is negative 6 over negative 2, which leaves me with 3. X equals a positive 3 is the axis of symmetry. All right? So we've got the axes of symmetry, but now we got to figure out how to find this vertex. If you guys remember, last example, I said that the axis of symmetry and the x term of the vertex are going to be the same all the time, every time, right? As long as we're dealing with these parabolas for all intents and purposes, that's always going to be the case. So here's what I'm going to do. I am simply going to take this number and plug it into the equation to find the corresponding y value. I'm going to say it again because you want it twice. I'm going to take this term, this negative b over 2a, I'm going to plug it into this equation in order to find the corresponding y term, and that, my friends, will give me the vertex. So matter of fact, I'm so cool, I already have half of it, negative 1 comma something else. I already have the other half of it, 3 comma something else, and that's what I'm looking for here. Remember, so the axis of symmetry is the x term of the vertex is always the same thing as the axis of symmetry. All right, so now I'm going to plug it in and do my thing. So basically I'm plugging in negative 1, so I've got 2 times negative 1 quantity squared plus 4 times negative 1 minus 3. That's going to give me 2 minus 4, which is a negative 2 minus 3, gives me a negative 5. You guys will let me know if my math is completely wrong. So my vertex here is negative 1, negative 5. Look, I'm doing it without actually having a graph. Woohoo! Let's do this next one. So if I take this 3, I'm going to have to plug it in here. So I have negative 3 quantity squared plus 6 times 3 plus 4. So negative 3 squared is 9, but it's a negative on the outside, notice that. So that's negative 9 plus a 6 times 3, which is 18. So that's negative 9 plus 18, which is a positive 9. Positive 9 plus 4 is going to give me 13. So the vertex here is 313, and that is how it's done. All right, let's see if we have another example. Just one more, oh, 2 more. Let's see how quickly we can get through these. Maximum and minimum values. So this is actually cool because we kind of thought about this concept before. Determine whether the function has a maximum or minimum value. Remember when we first started talking about the vocabulary, I mentioned that some parabolas are going to be happy, some are sad, and I told you with the first example that this number is going to determine whether it's happy or sad. Do you remember if this is happy or sad? Like I would say negative, sad, yeah. So it's negative, it's sad. So this is a parabola. When I graph it, it will be oriented in a sense downward, okay? So determine whether the function has a maximum or minimum value. Clearly this function has a maximum, right? Maximum seems like high, and then but it's going down, so it's a little oxymoronic. Like, wait a minute, how could the thing going down be maximum? But remember, maximum just means it has a point from which it can go no higher. So in this case, this one does have a maximum. So that answers that. That's the answer to the first part. This next one, it says state the maximum or minimum value of the function. How on God's green earth are we supposed to? Oh, I got it. We can use the vertex. So as long as I can find the vertex, and we learned how to do that in the last example, we got this going on. So the first thing we want to do is do x is equal to negative b over 2a. After we get this, we know that this is the axis of symmetry. We're going to plug that into the equation to find the corresponding y value, okay? And then we're going to have the vertex, which is going to give me the maximum, or in this case, the maximum value. So let's do it. Negative b over 2a in this case is going to be a positive 4. So x is equal to positive 4 over, now I'm just doing negative b over 2a, negative and negative 4 is a positive 4, over 2 times a, which is a negative 2 times a positive 2, which gives me a negative 4. So I end up with negative 1. So the first thing I know is that I have a negative 1 as my x term of my of the vertex of this parabola. Now I'm going to plug that -1 right back in there. So when I plug a -1 in here, it becomes a +1. So I get a -2. So this is going to be, let's do it out, -2 times -1 quantity squared minus 4 times -1 plus 6. So when I do all of this business, I get a -2, a +4, which is going to give me a +2, and a 6, which is going to give me an 8. You can go ahead and check my math. Let me know if I'm wrong. State the domain and range of the function. So now what I know is that this graph, I'm just thinking about it, is going to do something like this. This guy is going to be at -1, +8, and it's a sad parabola, okay? Goes down like that. So can I now determine the domain and range? You bet I can. The domain basically, again, is all x values that make sense in this case, and all x values are cool here. So all x values such that x is an element of the reals. Why did I say that? Because there's no x value that I cannot plug into this that will cause some kind of imaginary number to appear or something weird or some problem that I can't do. So that's cool. And so my range, I'm still, even though this says f of x, I'm still going to say y. I'm going to use y as the language because I think we understand that and that feels comfortable. So y such that all y's, such that, such that y is what? Well, in this case, if you know that this is the maximum, if we get as high as 8 for my y value, as I got my vertex, then I know that that's my maximum. I know everything below that. So I know it's going to be a part of what my y values can be. So I'll say y less than or equal to 8. And that's my range. Guys, I think that you have had enough math for the moment, especially with this lesson. And I actually do think that these examples are really important enough that we can stop here. I won't do example 5. I'll let you go on it, especially since this became a double video and I didn't think it would be, so I apologize. I cannot wait to talk to you later. Please let me know if you have any questions. Email me, talk to me in class, do whatever you need to do, but let me know how you're doing with it. I can't wait to talk to you. Take care, guys. Bye-bye.